Hello everyone. So back again to problem 3640, which is Trionic array 2. So reminder what the problem is asking us to do. We need to return the maximum sum of subarray with a trionic shape. What is a trionic shape? So a trionic shape should satisfy this condition. First segment, for example, from index I to G, the subarray should be strictly increasing. Then from G to K, the subarray should be strictly decreasing. Then from K to N, the subarray should be strictly increasing. This is the trionic shape. And we need to return the maximum subarray sum, which has this shape. This is what the problem is asking us to do. So if we make small observations, we can see that we have three possible states. The first one, we are still in the first increasing segment. The second one, we are in the decreasing segment. So we have finished the first increasing, then reached the decreasing phase segment. And the last one, we have reached the last increasing segment. So we will define three arrays. The first one, we will call it increase. The second one, decrease. The last one, we'll call it increase 2. Increase 2 will be initiated to minus infinity for and the size for this table is equal to length of nums. So the first array increase will indicate to us the maximum subarray following increasing shape at index I. For example, at e equal to 1, ink of 1 will be equal to 4 because we have 1 plus 3 equal to 4. And for the second array, which is decrease, we will call it. We are in the decreasing phase. This array should indicate to us the maximum subarray at index I following this shape, increase then decrease. So for e equal to 2, for example, decrease of 2 should be equal to increase of I minus 1, which is already 4, plus nums of I, which is 2. So decrease of 2 will be equal to 6. This is the transition that we will do. Same thing for the last array. So the transition that we will do, so increase 2 of I will be equal to decrease of I minus 1 plus nums of I, equal to the maximum between decrease of I minus 1 plus nums to I. So we are moved from the state decreasing to the state increasing, or we are already we still in the last segment. So will be equal to decrease of decrease of I minus 1 plus nums of I. This is the idea. So for the first array, so increase of I is equal to the maximum between nums of I plus nums of I minus 1, or increase of I minus 1 plus nums of I. We if we are still in the increasing phase, and the second array, if nums of I is lower than its previous one, either we will do the transition. So if we do the transition, decrease of I is equal to increase of I minus 1 plus nums do E, or we or the maximum between, or the is equal to decrease of I minus 1 plus nums do E. So we don't do transition, but we just we just increment the value of nums do E to decrease of I minus 1. And the last segment, either also we will do a transition. So increase of increase of 2 is equal to the maximum. If we do the transition, is equal to decrease of I minus 1 plus nums do E, nums of I, or increase of I minus 1 plus nums of I. In that case, the second, if we don't do the transition, we will we are already in the last segment, but the last segment it's we added the new element to the last segment. We keeps decreasing, and the value that we will return is the maximum element of increase 2. This is the overall idea. So let's try to implement our solution. So as we have 3 arrays, and each one, the first one, we will call it increase 1, the second one decreased, and the last one is increase 2. So the first array will indicate to us the maximum sub array ending at I following increase shape, and the second one decrease the maximum sub array ending at I following increase then decrease shape, and the last one maximum subarray ending at I following increase decrease then increase again shape shape, and the value that we will return is the maximum element of the array increase 2. So we will initiate our tables to minus infinity. So of nums. So, and we will iterate our table just one time. we will have a linear time complexity for I in range of 1 to ln of nums. So uh, if nums of I is bigger than nums of I minus 1, we will update our first table. So increase 1 of I is equal to the maximum between increase 1 of I minus 1 plus nums of I. If we are already in the increasing phase, or nums of I plus nums of I minus 1. And if nums of I is lower than nums of I minus 1, we will update the second table. So decrease of I is equal to the maximum. Either we do the transition. If we do the transition, so decrease of I is equal to increase 1 of I minus 1 plus nums of I. We have moved from increase to decrease, or we are already in the decrease, so we add to decrease the value of nums of e. So decrease equal to the maximum between increase I minus 1 plus nums of e, or decrease of I minus 1 plus nums of I. That's it. And here in the last, we will update the third table. If nums of I is bigger than nums of I minus 1, then increase 2 of I is equal to the maximum between, either we do the transition, so decrease of I minus 1 plus nums of I, or or we are already in the last segment, so we just increment nums of I to increase 2 of I minus 1. So decrease 2 of I minus 1 plus nums of I. Not increase 2. Increase 2. That's it. And we will return the maximum of increase 2. So this is our solution. This solution is called this approach is called the dynamic programming solution with state transition. And the time complexity for this is linear, and that's it. It's the implementation is easy. Just it's clever idea. Hope you like it, and bye bye.